Hello everyone, welcome back to this introductory series. Now today we will recall Newton's laws of motion and we will look into a new concept of free body diagram. So what was Newton's first law? It is also known as law of inertia. It states that an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. So in simple terms, this law is jaise the. That is, if it is moving, the object will remain in motion. If it is stationary, the object will remain stationary. The only thing that could change this state is an applied force. Okay? Clear everyone? Now let us move to the second law. Second law states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. Okay? So, the rate of change of momentum of the object will be in the direction of the force. Now, if you have a ball, if you apply force in this direction, the ball will not start moving in this direction. Okay, the ball will move in the direction of the applied unbalanced force. Remember, for motion to occur, the forces have to be unbalanced. Balanced forces will not result in change in state of motion. Now this law gives us the famous equation force is equal to mass into acceleration. So second law is the one that gives us force is equal to mass into acceleration. Now what is the third law? Newton's third law states that when an object exerts a force on another object, the second object instantaneously exerts a force equal in magnitude and opposite in direction back on the first. So when my fist hits my palm will also exert a force equal in magnitude and opposite in direction. Because force by fist was in this direction, force by palm will be in this direction and their magnitudes will be equal. Important point to remember here that both these forces will be acting on two separate objects. So force applied by the fist is acting on the palm and force applied by the palm is acting on the fist. So these forces will not be acting on the same object. They will act on two different objects. Now, what exactly is free body diagram? Free body diagram is diagram of an object with all of its forces and it will help us to find the object's acceleration. So let's consider an example. So let's say on a table an object of mass m is lying. So how to draw free body diagram of this object with mass m? So we will take object with mass m. Which is the force that will always be present? It will be gravitational force. So gravitational force will act always below and that will be m into g. M into g will be gravitational force. Now if this was the only force acting, the box or the object had to fall below, but it is not falling. Therefore, another force is acting which will balance this force and that would be the normal force acted upon the box by the table. So that will be exactly in the direction opposite to the gravitational force. We denote it by N. This force is the reason why the object does not fall because table is also pushing at the object. Okay, so this will be free body diagram of a stationary object resting on a table. Now what happens if we, let's say, apply a force F in this direction. So here, along the vertical direction, the forces are balanced. But along the horizontal direction, the forces are not balanced. So, in this case, the object will obtain an acceleration in this direction, in the direction of the unbalanced force. Here we are assuming that the table is frictionless. Okay. So therefore no frictional force is acting. But if there were a frictional force acting, then how will it act? It will act in this direction. So frictional force always acts in the direction opposite of the motion. Now what would be the acceleration? Here acceleration would be F divided by m, because the only unbalanced force is F in this direction, and we are assuming right now that friction is absent. Okay, we are assuming that the surfaces are frictionless. So this in general is a free body diagram. Now let us see a pulley system and how to calculate accelerations of two objects that have been suspended using a pulley. So let me just draw a diagram. We are assuming that the pulley is frictionless. So two objects have been suspended. Let this mass be m1 and let this mass be m2. Now, if m1 is greater than m2, you can say with intuition that m1 will go down and m2 will go up. But how to prove that exactly? So here we will use free body diagrams. So let us draw free body diagram for object 1. So we have object with mass m1, therefore the first force that will be acting on it will be force of gravity. That will be of the value m1g. Mass is m1 and acceleration due to gravity is g. So this force is m1g. So is this the only force acting? No, because it is suspended by using a rope, there will be a force of tension. So if you pull something, the string or the rope becomes tense. So that is called force of tension. So tension T will be acting on this object. Now let us move on to object 2. So for object 2, again for object 2, first force is m2g and again tension T. See, a rope or a string will always pull. It can never push. Okay? Because we cannot push by using a rope. A rope always pulls. So these are the free body diagrams. Now see, the forces are unbalanced. So what will happen? The objects will have acceleration. Now with intuition, we know m1 will go down, m2 will go up, because we have assumed that m1 is greater than m2. So this object will have acceleration a in downward direction, but जेवढा m1 खाली जाणार आहे m2 तेवढाच वर जाणार आहे, कारण का रोप तर एकदम व्यवस्थित राहणार आहे ना, रोप मध्ये स्लॅक घेऊन उपयोग नाहीये. So m1 will also move up with acceleration a. So m1 will have acceleration a in downward direction, m2 will have acceleration a in upward direction. So let us write the individual equations. So acceleration A, mass m1a will be the net unbalanced force. So it will be m1g minus t, and therefore we will get T is equal to m1g minus a. Okay, this will be tension T. For object 2, we will get m2a is equal to T minus m2g. Therefore, T will be m2a plus g. Now, both these tension are the same. So, we will equate them, and hence we will find m1g minus a is equal to m2g plus a. Therefore, m1g minus m1a is equal to m2g plus m2a. Therefore, m1a plus m2a becomes m1g minus m2g. Therefore, a becomes m1 minus m2 upon m1 plus m2 into g. So this will be the acceleration of the objects. So object 1 will move below with acceleration m1 minus m2 upon m1 plus m2 into g, and object 2 will move up with acceleration m1 minus m2 upon m1 plus m2 into g. Hope you have understood this concept. Let us meet tomorrow. Thank you.